Okay, now we're going to tackle or discuss operations with complex numbers. Remember the operators: add, subtract, multiply, divide. And we're going to focus and then raise in a power to a power. Okay, so adding and subtracting, you can only add or subtract like terms. But let's talk about multiplication. Well, when you have rectangular form, so this is rectangular form, you have just numbers that you're dealing with. So when you're just dealing with numbers, you're going to do multiplication the way that you normally would. You just need to remember what the multiples, when you multiply I, right? I to the first is I squared is -1, I cubed is -I, and I to the fourth is +1. Okay, so you just have to remember that. So you're just going to multiply. And for division, remember when you're dividing imaginary numbers, you have to multiply by the conjugate. So this would be A2 subtract B2I. And you would multiply both the numerator and the denominator by that. And then you would simplify. And for raising a complex number to a power, you would just expand. Think about A plus BI times A plus BI times A plus BI. You could multiply these two first, get that result, then multiply that result by another A plus BI. You could also use binomial theorem to do the expansion. Okay, but now when we have R's and thetas, the thetas follow the rules or laws of exponents. And the R's, which are real numbers, just follow these rules, number rules, right? So when we are multiplying, so if I had this thing multiplied by a whole nother, say R2 cosine, if I had two of those terms being multiplied, you multiply the two R's together. And then what are the rules, the laws of exponents? X squared times x cubed. When you multiply powers of the same base, you add the exponents. Well, the thetas follow those laws. So when you're multiplying the thetas, you end up adding them. So and then when in dividing, if you had this term divide another one of those terms, right? But this would be a different theta. I'd call it theta 2. And we'll call this R2, R1. Right? So the R's are just numbers, so just divide the R's. And because the thetas follow the rules of exponents, when thetas are divided, you end up treating that as subtraction. Just like if you had x to the fifth over x squared, it would become x cubed because 5 subtract 2 is 3. And then when you raise a power to a power, the R gets raised to the power, right? If you have R squared to the n, that would be 2 times n, right? And then because when you raise a power to a power, you end up multiplying, you multiply the thetas. Okay, so let's do an example. Here we have an A plus BI being divided. So you're going to multiply. In this case, it's not the conjugate because there's not two terms down here. We just have to multiply the numerator and denominator by I. Well, I times I is -1. -1 times 3 is 3. -3 times I is -3i. -3i times I ends up -3 times -1, which is +3 times √3. And then these all have a 3 in common, reducing it to -I plus root 3, but when you put it back in a plus bi form, doggone it, we have root 3 subtract I. All right, let's do one of these. We're going to do a division one. So remember, this is the R1, and this is R2. So the R's get divided, and then the thetas get subtracted. Subtract each other. So 4 divide 2 leaves 2, and 2 over root 2, you'd multiply top and bottom by root 2. Well, root 2 times root 2 simplifies to 2, and then the 2's cancel. Oh, I gave it one more shot. Leaving root 2. Okay, so R is now root 2, and then 60 subtract 135 is negative 75 degrees. And then this division problem up here simplifies to this right here. And then if we've got something raised to a power, remember it's R to the 5th, and then here's the setup down here. It's R to, when you've got a polar trig form, or a complex trig form, sorry, being raised to the power, it's R to the n, and then the thetas get multiplied by the n. So this is what that would look like. It's root 33 to the 5th, and then 5 times the theta, and the theta is 30. Well, root 33 to the 5th is root 33 times root 33 times root 33. You get the idea. Five times it multiplies itself. Well, we've got these pairs. This root 33 times this root 33 ends up being 33. And then there's a pair. That simplifies to 33. And now when you type 33 times 33, whoops, I left off a 3 right there, you end up with 1089 root 33, and 5 times the theta is 5 times 30, which is 150. And now you could put it, you could put it back in the correct form. 1089 root 33 is the R times cosine 150 degrees plus I sine 150 degrees. All right, that's it for operations with complex numbers.